Okay, grade 9s. We are starting our next unit, which is inequalities. Now we're going to jump right in with a little bit of a warm-up here. And with this warm-up, we see that there's two numbers with a blank in between. And in between those two blanks, we're going to put one of these following two inequalities in between them. Then we're going to translate what that statement says in English. Now, just a little quick reminder that when we're reading, we know in English we read from left to right. So once I've put that inequality symbol in between, I want to make sure that when I translate it such that I'm reading the 4 before I'm reading the 7. So let's just do the first one together here. When I put the symbols in between, I know to have the symbol in this direction. Oftentimes, people are taught to think of the inequality symbols like the mouth of an alligator or mouth of like a Pac-Man or something like that. And that mouth is always going to want to eat the larger number. Now, that's still very true and very accurate, but it doesn't really help us with our translating. But luckily, when we're taking a look at these number statements, we should be able to, from context, say what that statement means. So I know 4 is less than 7. So I can translate to English and simply say 4 is less than 7. That's what it means. I'd like you to take a pause on the video and complete the remaining 5 examples. Once you've done that, unpause the video and we'll do the rest together. Go! All right, welcome back. So we're going to take a look at the next ones. I'm going to go through them a little bit more quickly. So I have -2 is also less than 7. I have 0 greater than -7, though. Greater than -7. I have -6 being greater than -9. And then I start looking at these fractions. Now, these fractions are ones purposely, intentionally chosen from ones that we should be fairly familiar with from Unit 1. But if those are things that we're like, oh, we need to convert these to decimals, because maybe that's how your brain functions, it's easier for you to do that way. Here are some conversions for you. 1/2 is the same as 0.5. 3/4 is the same as 0.75. And then I can go ahead and compare. I know 0.5 is less than, or 1/2 is less than 3/4. And then my last one, I know that 0.125 is also less than 0.3. Now, just to kind of point out the whole intention behind this warm-up here is that, like I said, most people know where to, or how to put the inequalities in between the two signs or between the two numbers when I am dealing with those two numbers. But if I didn't give you two numbers and I wrote down that symbol, more of us have difficulty reading what that symbol means without those numbers there to help us understand the context. So I simply wanted to point out what we already know and that consistency in what it always translates to. Just like when we read our sentences from left to right, we also read our symbols from left to right. Now, when I take a look at an inequality symbol, and I'm looking specifically at the symbol here, the smallest side is on the left. So I read that as less than. When I take a look at this symbol here, the bigger side's on the left. So I read that as greater than. And those two inequalities are ones that we should be rather familiar with. So this first symbol here, the big side is on the left. So I would read that as is greater than. oops, not greater, greater than, okay. And this symbol here would translate to is less than, because the smaller side is on the left. And I read from left to right. Now the next two symbols look oddly familiar. They look pretty much like these, except they have this single horizontal line underneath. Now that single horizontal line has a really important meaning, and it changes that inequality symbol. Now you'll notice there is a similarity, so this guy being is greater than, and this guy having the same direction of that inequality symbol, there is a similarity. So I would still say that this is greater than, but that horizontal line underneath implies that it is greater than or equal to. So the threshold that I'm trying to meet can include that value. So say I want to buy raffle tickets for the SMA auction, and I want to spend at least $10 on auction tickets, okay? Well, that implies that I could spend exactly $10. The amount I donate or purchase can equal to $10, but at least also implies that it could be more than $10. I can spend 11 or 12 or 15 or 100. That also satisfies what my goal was. So when I talk about that symbol with the greater than and that line underneath, it implies that my answer can also be equal to as well. And then similarly speaking, this last symbol says that it is less than or equal to. So just to summarize, that line underneath the inequality means that the value of the stated is included in the list of possibilities. So I want to spend at least $10. That means whatever amount I want to spend is greater than or equal to 10. 10 is included in the list of possible answers. Now, taking a look at inequalities, inequalities exist such that we can have more than one possible answer. I want you to pause for a moment, and I want you to look at these two inequalities. I want you to translate what they say, right? So I have X, match the symbol, and then there's 17, okay? But I also then want you to figure out 3 values for X that possibly satisfy that inequality, which means if I substituted that value in the spot of X, it would make the inequality. So this reads as X is less than 17. What's the number less than 17? Well, it could have 16. Okay. What other options do I have? I could also say X is 7. I could also say X is a quarter. I could also say X is negative 12. I have lots of options, but there's some options I cannot include. Because I have a less than symbol and a not a less than or equal to symbol, 17 is not a possible solution. 18 isn't either, 19 isn't, 20 isn't, etc. But any number that is less than 17 is a possible value for X. Can you try the next one on your own? Pause the video and go. Welcome back. When I take a look at this, this reads as X is greater than or equal to positive 2, which means X can in fact equal to 2. I have that or equal to portion. X can also be 3. It can also be 5,427. Okay. In this case, X is allowed to be equal to because of that or equal to portion, which means that value of 2 is included in the list of possible values. Okay, now that we've kind of gone through some definitions here and we can understand some symbols maybe a little bit better, we're now going to just compare equalities versus inequalities. So an equality, also sometimes referred to as an equation, is simply a math statement that shows that two things are exactly the same in value. The symbol that we use is an equal sign. A numerical example could be x is equal to 5. A contextual example can be you must be exactly 5 years old to vote in the kindergarten election. Okay. In an equality, there is only one solution that makes the statement true. So if I'm talking about the contextual example of you must be 5 years old to vote in the kindergarten election, you have to be exactly 5. That's the only possible age you can be. There's only one possible solution, and that solution is that you're 5. Okay. An inequality is different. An inequality is a math statement that shows two values are not necessarily the same. One might be greater or less than the other. Now, in inequalities, we've got more options for the symbols that we use. We can have a less than, a greater than, a less than or equal to, a greater than or equal to symbol. All of them are inequalities. A numerical example can be x is greater than or equal to 18. A contextual example can be you must be at least 18 years old to vote, which means I can be exactly 18. I could have turned 18 today, and then I could vote. But I could also be like 47 or 25 or 106. Okay, when I say at least 18, and I'm talking about an inequality, inequalities have many possible solutions. It's not just one. There's many possible answers that can exist. So in this context, I could be 18, 19, 25, 40, 100, and a whole bunch of other numbers, but there's so many numbers that I couldn't possibly list them all right now. Now, when we talk about inequalities, there is a little bit of a difference because there's multiple solutions and because there's multiple inequality signs. Now, in an equality, an equation, it shows that both sides are equal. They're the same, no matter what the order is. And because the order doesn't matter when I'm writing an equation, I can swap the order of the values on both sides of the equal sign and still get a statement that's true. So say, for example, I have a cousin and he's 12 years old. I can say X, the age of my cousin, is equal to 12. But if you had told me the age of 12 is equal to the age of my cousin, I swapped the order of the 12 and the X. Notice that equal sign still holds. I don't have to change the sign in any sort of way because changing the order of the X and the 12 doesn't change the validity of what I'm saying. What I'm saying is still accurate, it's still true, it still has all of its meaning. Now, inequalities are a little bit special because there's so many symbols that they can take. So an inequality shows that one side is less than or one side is greater than the other. And in an inequality, the direction really, really matters. Because saying like 4 is less than 6 is really different than saying 4 is greater than 6. One of those things is inaccurate. So if I wanted to swap the order of the values in a statement, I also need to reverse the direction of the sign. Which means if I have this symbol here, a greater than symbol, and I want to change the order, so instead of saying 6 is greater than 4, I wanted to have the 4 come first and the 6 come last. In order to keep this statement accurate and not change what it's saying, I need to reverse the direction of the sign. Because 6 is greater than 4 is an accurate statement. 4 is less than 6 is also an accurate statement because that sign flip is necessary. So, here are a whole ton of inequalities. I want you to reverse all of the orders and change the inequality accordingly. Can you pause the video and give those a go? Thank you. Also, welcome back. Okay, so in all of these, I'm simply going to swap the order of the values on both sides of the inequality. Here I had a greater than symbol to begin with. Now I have a less than symbol. For the next one, I'm again swapping the order of the values on both sides. Before I had a less than or equal to. Now I have a greater than or equal to. Swap the order of the numbers. Before I had a greater than or equal to. Now I had a less than or equal to. Now, I'm not going to lie, these first three examples are easier than the next three because I have numbers and I know the value of both sides of the inequality, and I know that if I wrote 3 and 5 and I asked you to put an inequality sign in between, you don't need to think about what the inequality was before and think about what you have to do to flip it. I know that you know that 3 is less than 5, and 19 is greater than -2, and 0 is less than 1. I know you can put that inequality in the proper order. The one difference that maybe you wouldn't have done if I didn't show you the original inequality is that if I have a less than or equal to or greater than or equal to symbol to begin with, then when I flip the order, that or equal to portion still exists. And if it wasn't there before, then it's not going to be there after. Now, what we do need to make sure that we're remembering is that we have to flip the sign when we flip the order, specifically when I don't have numbers on both sides, because that's not something that we can technically just look at the values and know the direction of the inequality. It's not necessarily obvious to us. We have to remember to make sure that flip still happens. So if 6 is less than x, that means x is greater than 6. And if 12 is greater than x, that means x is less than 12. And if -23 is less than or equal to y, that means y is greater than or equal to -23. So that really, really matters. And we're going to talk about this kind of contextual piece where I have a variable involved, and we're going to talk about defining variables and all of that again. But when we eventually write inequalities, we want that order to have the variable first, the inequality symbol, and then the number last. Just like in solving equations, standard form always had the variable first and the number last, and we had an equal sign in between. Same goes for inequalities. So speaking of inequalities and writing our own and doing so from context, that is our next task. So we want to write basic inequalities from a word contextual statement. When we do so, we need to define our variables using a let statement. We know how to use let statements. We say let X represent, and then we say exactly what it represents. Maybe I'll say let A represent the age of a voter. Maybe let X represent the number of cookies I want to eat, right? It can represent anything. I want to make sure it's well defined. I would never say let X represent cookies, but I could say let X represent the number of cookies, okay? But I want that clearly defined variable. Next, I want to write that inequality in. And just as I mentioned before, there is a standard form my inequalities should be written. I should have my variable first, my inequality in the middle, and my number last. So X is greater than 6. Awesome. 6 is less than X. Not in standard form. Okay? Notice that when I wrote these examples and I swapped the order, I swapped the direction of the inequality too. But even though they're saying the same thing, there's a proper final form for an answer. So we want to make sure that we maintain that. Now, when we're taking a look at inequalities and writing them from context, okay, there are some keywords that we might want to be on the lookout for. So, of course, we are now familiar with these symbols, okay? And I can define those symbols exactly how we define them, and I don't think there should be much confusion about which symbol's which once I get that kind of in my head. But you'll notice that there's other language options that exist to say the same thing. Kind of like I can say the words is equal to, or is the same as, or what else can I say? Gives me, like the sum of two numbers gives me 12. Okay. Is another one that equal can represent, or can, an equal sign can be translated to. Just like there's more than one way to say is equal to, there's more than one way to say all of these different inequalities. So for greater than, I could also say more than, I can say exceeds, or I can say over. For less than, I could also say fewer than, under, below. For greater than or equal to, that's when I'll see words like at least, a minimum of, or no less than. No less than is one of those that sometimes people get confused by because they're like, less than, ooh, a symbol of less than. But when it says no less than, I'm literally doing the opposite symbol. Less than didn't have an or equal to portion to it, so no less than would. Okay. And then my last one, less than or equal to, I can say at most, a maximum of, up to and including, no more than, or does not exceed. Now, this is not the full, complete list of every single type of wording that could ever be used ever. But as we were kind of creating these notes, I wanted to make sure that we included as many as I could possibly think of at the moment. So, here's the first set of examples we're going to do. Oh no, this says example 3 again. It should say example 4. Okay, the first example, example 3 here, says write an inequality that represents the statements below. For each scenario, let x represent the unknown number. Okay, so my variable has been defined for me. For each of these, I'm going to use x. I do want my final answer in standard form, so I've actually gone ahead and wrote x down, no problem. Now, what I'd like you to do is I'd like you to take a moment. I'd like you to look for some of those keywords in these statements, and I'd like you to finish off writing those inequalities. Pause the video, try it out. Welcome back. Okay, the first one, a number is less than or equal to, lovely. Less than or equal to, and it was less than or equal to 7, so I'm just going to pop a 7 there. The next one, a number that exceeds. I could see that exceeds implies that it's greater than, and it is exceeding 15, so x is greater than 15. The next one is this, a number can reach a maximum of 294. A maximum of means that it can equal that value, but it can't be more than that value, so it has to be less than or equal to. And that's where we saw a maximum of over here, 294. And the last one says is less than, well, there we go, is less than, and this time the number is 5. Now we have 4 examples where we're doing the same thing, except we're providing context. It's just not a number this time. It's an actual scenario. So in each of these, we need to make sure we're defining our variable, and then we're going to write an inequality. I'm going to do the first one with you, then you're going to try the next few on your own, and we're going to do them together afterwards. So the first one, you must be at least 16 years old to join a youth volunteer club. Now notice it doesn't say a number must be at least 16. It says you must be 16. And what about me? It's my age. So I'm going to say let A represent my age. Okay. And so I have A, and it must be at least 16 years old. I'm looking at my chart there for at least. At least is greater than or equal to. So is A is greater than or equal to 16. Okay. Please try the next few on your own, and then unpause the video when you're done. All right, Zenon is going to the movies to catch the latest Spider-Man movie. He wants to spend no more than $15 on snacks at the movie theater. So I'm going to say let X represent how much he spends on snacks at the movie theater. How much Zenon spends on snacks at the movie theater. And I know that I have X representing how much he's actually spending. And he says no more than 15, which means I can be less than, and I could be equal to 15. To receive a student discount, you must be under 18 years old. Okay, let A represent my age again. Here, I want to be under 18 years old, which means my age has to be less than 18. Last but not least, to avoid extra charges on your phone bill, you can use a maximum of 15 gigabytes of data each month. Okay, so my statement here says, I'm going to say let D represent the amount of data I use each month. And it says the amount of data I use is a maximum of 15 gigabytes, so less than or equal to 15. Okay. Now, there is some practice that follows, so please spend some time working through that. But I want to point one thing out with notation really, really, really quick. Now, specifically the less than symbol. Oops. This less than symbol is different from the angle symbol. The angle symbol has this horizontal line associated with it, and this angle kind of moving upwards from it. Whereas this symbol, this less than symbol, is kind of like the capital letter V if I picked it up and I rotated it. There's no horizontal chunk to it. Okay, it is not going straight sideways. You could also think about if I wrote the letter K as a lowercase or an uppercase, and I just get rid of this straight up and down, the vertical part of that letter. That's the symbol I have to represent less than. Now these symbols look very similar, so I get it that it's hard to make them exactly perfect, but I do want to point out that they are different from each other. And if I were to type these symbols, you should be able to tell the difference. But also from context, we should be able to tell the difference, so it shouldn't be something that we confuse too much. But I just wanted to point that out so that we're all on the same page when we're starting to practice drawing those symbols ourselves. Otherwise, that is it. I hope you have a lovely day, and I will see you next time. Bye.